Non-terrestrial network systems operate above the Earth's surface using platforms like satellites, in Earth's orbit, drones, and high-altitude platforms. Unlike traditional cellular networks, which covers less than 20% of our planet, NTN provides extended coverage to remote areas without traditional terrestrial network. NTN NB-IoT is one of the key topics and lead deployments for satellite direct-to-device communication. And here we have our setup, which can emulate the NTN network
and enable RF measurements on DUT that can make call connection as NTN NB-IoT.
The core instruments of our solution is radio communication analyzer NT-8821C. Having full control over the network and its parameterization has inherent benefits. During the tests, we need to deal with things like Doppler shift and also propagation delay, which is caused by the distance between the satellites and the device on the Earth's surface. The NTN DUT on Earth detects the System Information Block 31, where the information about the satellite position is broadcasted. The delay then between the satellite and the DUT is calculated based on the System Information Block 31 in the network and the actual position of the DUT. So now we are going to look at the step-by-step process of the measurement. First, we connect the RF port of the DUT to our instrument MT8821C. Next step is the parameterization of the network. So we need to set fundamental parameters like input power level and output power level. One of the key requirements is to test sensitivity of receiver of the DUT by emulating low power received signal. By applying repetitions, we can go as low as minus 138 dBm. Then we need to set the correct test SIM card profile, and also important is to set the System Information Block 31, where longitude, latitude and altitude of the DUT are defined, which needs to match with the position defined in the DUT to correctly calculate the propagation delay. We will power on the DUT and wait for the initial registration and connection to emulated network. Once DUT is in connected state as displayed, we are ready to make measurements. After pressing single or continuous button, MT8821C will run the measurements. Measurement results are shown in the central window of MT8821C. There we can see numeric values, spectrum emission mask, IQ diagram, and more. Working with Anritsu's radio communication analyzer MT8821C is very intuitive and easy to use thanks to its innovative design. It enables various transceiver and receiver measurements according to the 3GPP standard. NTN is a key technology that has begun to revolutionize the world of telecommunication and will become an integral part of the future wireless networks.